Well, good afternoon. In this video, I will be walking through my solutions for week 4 homework, which involves financial calculations, stock analysis, bond pricing, portfolio risk assessment, loan amortization, and risk metrics. Let's get started. So I started by creating, here I'm going to expand it. Started by creating a function library for financial calculations. I used the NumPy financial library, which provides functions for present value, future value, net present value, and internal rate of return. For example, the PV function calculates the present value of future cash flows given an interest rate, number of periods, and periodic statement payments. Similarly, the future values functions determines how much an investment will be worth in the future. NPV and IRR are crucial for investment decisions. NPV discounts future cash flows to the present value, while IRR finds the rate that makes NPV equal to zero. These functions allow us to evaluate investment opportunities efficiently. At the end of this section, I I tested the functions by calling PV with the sample parameters and printing the results. So what I did, I just created a separate file that was a Python format, Python file, and had all the functions. I just copy and pasted it from here, and then I imported it as a module, which we can see right here. Import financial calculations as FC, and then I just used it to find the present value. And then moving on, next I wrote a function. I wrote to analyze stock data. I use YFinance to pull stock prices and Fred API to fetch the risk-free rate from the Federal Reserve database. The function calculates daily logarithmic returns, 30-day rolling volatility, and the Sharpe ratio, which measures return per unit of risk. The Sharpe ratio is important for comparing investments with different risk levels. And I made the program interactive by asking the user to enter the stock ticker. After fetching the data, it prints out the average daily log return, volatility, and the Sharpe ratio. So as we can see here, the output, we did it for Microsoft, and we got the average daily log returns, which was negative 0.006. 30-day rolling volatility annualized was 0.2829, and the Sharpe ratio annualized was negative 0.8259. And then here's our calculations for the functions, and then now we take the input from the user, and then we just put this in the try block to see if there's any errors. And then moving on to exercise 3, bond pricing function. In this section, I created a function to calculate bond prices based on the face value, coupon rate, years to maturity, and market interest rate. Bonds are evaluated by discounting future cash flows, coupon payments, and face value at the market rate. So the formula I use follows the standard bond pricing applications, which are calculations, which you can see in this line right here, which I highlighted. And then it returns the price. And then moving on to exercise 4, here I developed a function to analyze portfolio performance giving stock ticker and weights. The function number 1 pulls stock price data, calculates daily returns, you can see here, and then computes portfolio return and risk using weighted returns to standard deviation. So the function also displays annualized stock returns and risk, helping investors assess multiple portfolio performance. And a way to optimize this function would be to, if we had access to a database or any records that would show how the weight for each stock in the portfolio, because here we had the user input it manually, but ideally we would want that automized and then put out in a report. And then on exercise 5, in here we can see the output, which I just inputted I put Apple and Microsoft. And then we see the portfolio return, portfolio risk, and then we go down in the second section, we do the individual stock returns. And then we go to exercise 5. I then created a loan amortization function, which calculates periodic payments and generates a payment schedule. It considers loan amount, interest rate, term, and payment frequency. This is what our parameters would be for this function. The function breaks down each payment into principal and interest portions, updating the remaining balance. So that's why we have a for loop right here that does it. It loops over each period to generate an amortization schedule. And then the program prints a table showing how the loan is paid off over time. And then again, we have our main function, and then here's an example of an output that we have. It's going to expand it, and then we see the payment period. This is a monthly payment for around, I think it was like 10 years. So we see now it just breaks it down for payment number, and then payment, principal amount, interest payment, and then the remaining balance. All right, and then if we go to exercise 6, we look at risk metrics calculations. Finally, I built a function to calculate financial risk metrics like beta, standard deviation, in correlation with the market. So we have our three main outputs, which are beta, measures the stock value sensitivity to the market movements. It also gives us a standard deviation, which quantifies price volatility. And then also we have the correlation, which shows how closely the stock follows the market. The function downloads stock and market index data, and then calculates daily returns and derives risk metrics. It then prints these values to help assess investment risk. So we can see here where it's downloading the stock data and the market data, which we both get the input from the user, and then we check we do some error checking. Then here we calculate the daily returns from the stock and the market. And then we just do more calculations here, calculating for beta, calculating annualized standard deviation or volatility, and then also calculating correlation between stock and market returns. And then here we just prepare the result as a dictionary as indicated in the instructions. And then we have our main functions that get the main two inputs, like we said, are the stock ticker symbol and the market index ticker symbol. Which here we have a couple, SPY and S&P 500. All right, here's our output. And that wraps up my week's Force homework. In this video, we cover financial calculations, stock metrics, bond pricing, portfolio analysis, loan amortization, and risk assessment. These are essential concepts in finance, and coding them in Python makes analysis more efficient.